In the last video, all of our quadratic functions were written in what we call standard form. And this is that transformation form of the quadratic function. So last time we were writing this as f of x equals a times x minus h squared plus k. And we saw that this gave us a lot of information about the graph, right? We could tell just by looking at it that the vertex had an x coordinate of 5, we would say that minus 5 would change sign and become a positive 5. The y coordinate will keep its sign, so it will be 5 comma a positive 2. Because that number 3 was positive out at the front, we know this is going to be an upward opening parabola. And it also has that stretch of 3, vertical stretch, where we multiply all the y coordinates by 3. Okay, so we really like standard form because it has all this information in it. Frequently what we end up with, though, is the general form over on the right-hand side, where somebody has come and FOILed out that x minus 5 and distributed the 3 and gathered up all the like terms. And now there's no way to just look at that f of x on the right and tell that its vertex is at 5, 2. These are actually the same function. If you go on Desmos and you graph both of these, you'll see that they're exactly the same quadratic function. It's just we get a lot less information from general form. And you might recognize that general form as the ax squared plus bx plus c that you used for the quadratic formula in high school. All right, and the use of the letter a in these two forms is not an accident. So this a that's stuck to the x squared, that actually always ends up being the same number. So there's a reason why we use that letter a in both forms. But we have the different numbers, b and c, over on the right, h and k over on the left, because those are not the same number. So our question is, how can we get from general form and reverse engineer it back to standard form so we can figure out where our vertex is? So the punchline of this is going to be that that number h for the vertex is going to be equal to negative b divided by 2 times a. And I'm just going to spot check to see if this works, and then I'll tell you where that formula came from. All right, so let's just spot check to make sure this works on this one. So if I'm over here on the right, if I want negative b, our b is this negative 30, right? So I'm going to plug in, there's a negative in the formula, b is negative 30 divided by 2 times a. I already circled a was equal to 3. All right, so I've got a positive 30 on top and a 6 on bottom, and that gives me 5. And we saw that 5 is the x coordinate of the vertex. So looks like this formula works. Where in the world did it come from? All right, so here I have both of our forms written, our standard form on the left and our general form on the right. And I'm going to see what happens when I try to write the standard form in general form and see if we can figure out where this negative b over 2a formula came from. Okay, so this is going to look like alphabet soup for a little while here. I'm going to FOIL out this x minus h. All right, so I'm going to leave the a hanging out front. Remember our FOIL, so the first terms give me x squared. The outer terms give me minus xh. The inner terms give me minus hx. And then the last terms are negative h times negative h. That's a plus h squared. And then this plus k is just hanging out at the end. It's actually going to keep hanging out for a few steps. All right, so I'm going to notice that in the middle here, x times h and h times x, those are really the same thing. So I've got 2 of the same thing in the middle. So I'm going to write this as a times x squared minus 2hx plus h squared plus k. All right, and now I'm going to distribute the a through that set of parentheses. I know, alphabet soup, I told you. Minus, let's see, I got a lot of letters here. I'm gonna write them all in alphabetical order. So I've got 2 times a times h times x. Then I've got an ah squared plus k. Right. This is actually as much simplification as you can do with this many variables laying around. What we really want to focus in on is the coefficient of the x. All right, so in the middle here, I've got minus 2ah as the coefficient of the x. Now, if this is going to be the same quadratic function as the one on the right, then that negative 2ah has got to be the same number as whatever b is. Right? So I have negative 2ah must be the same number as that number b, right? And if I solve that little relationship there for h by dividing by negative 2a, you get that formula, h equals negative b divided by 2a. All right, so that's where that formula comes from. Let's actually put it to some good use. All right, so I've got our little formula down there in the bottom right, h equals negative b over 2a, and we want to find the vertex of this function and then write it in standard form. So let's start off by finding the vertex. Okay, I now know how to find the x-coordinate, that h. It's going to be negative b divided by 2a. So let's go up to our quadratic function. We've got a negative 1a, a negative 6b, and a negative 5c written in general form. And then let's see, so I've got a negative in the formula. My b is negative 6. And then 2 times a, which is that negative 1 coefficient stuck to the x squared. And this gives me a positive 6 on top and a negative 2 on bottom, or a negative 3. All right, so I know that my vertex has to be negative 3 comma something. How do we figure out the something? Well, we just have to figure out what y-coordinate belongs to negative 3. So if my function is f of x equals negative x squared minus 6x minus 5, let's just ask the formula, what's the y-coordinate that belongs to negative 3? There's a lot of negatives going on here, so we got to be careful. So negative from the formula, plug in negative 3 for x, minus 6 times x, minus 5. Pay attention to your order of operations. Let's see. This negative happens after I do the square. So negative 3 squared is a positive 9. In the middle, negative 6 times negative 3 is a positive 18. And then minus 5. So I've got negative 9 plus 18 minus 5. That's going to be, let's see, 9 minus 5 is 4. All right. And that's the y-coordinate of your vertex. Okay, and that was the first thing they asked us to do. We used that negative b over 2a to find the x-coordinate and plug in the x-coordinate to find the y-coordinate. So there's our vertex. The other thing they asked us to do was write it in standard form. So let's remember that standard form is a x minus h squared plus k. The a, remember I said that the a is the same a in standard form as it is in general form. So this a up here, that's negative 1, that's going to be a in standard form as well. Okay, so f of x equals negative 1. You can just write it as a negative x. Minus h comes from the vertex, right? So minus a negative 3, or you can just think about changing the sign to plus 3 squared, plus k is that plus 4. All right. And there's our function. And if this was a homework problem and you wanted to check, you can go graph both of them on Desmos and see that you get exactly the same function for those two equations. All right, so that's all there is for quadratics and videos, and we'll finish up the rest in class.